Hello everyone, this is Ladybug Tools Honeybee Radiance video number 5. We are still using the Ladybug Tools 1.3, although you can use 1.4 if you want the latest version. It shouldn't really matter that much. You should be able to follow along and probably you have already an advantage. Still want to stick with 1.3 just because from a practical point of view everything runs fine at the moment and I don't want to change it now. I tested the 1.4 on my laptop and everything seems looking fine. I want to try to conclude this Radiance chapter, but there is still some tools we haven't looked at and there's still questions coming in. So there are going to be 2 videos. This one will deal with dynamic shades, context. Thanks Marcin, he actually brought it up. He asked me about dynamic shade properties, how the dynamic shades work and dynamic shade groups. What I can tell you already, the shade groups component, which doesn't actually work, it seems. I get an error, but dynamic shades work and I will show you how that, and we will go through that now. That's perfect because we need to touch the schedules, and I pushed this out of the way for a long time because I couldn't wrap my head around. I have a much better idea now, and yeah, we will look at that. That will also prepare us for the next chapter, which is the energy model, which will be more complex than the Radiance. And then there will be another video where we look at view-based analysis, which is actually rendering an image. So we can actually create images with Radiance. Okay, you still can remember where we are. We have our model. If you don't know what I'm talking about, please go back and watch the video series. This playlist, so you know what's going on. Before we start, so the last thing I did was the daylight factor, and I would just delete that. This was just a very simple daylight factor analysis. And before we start, I want to talk quickly about how to arrange or how to structure your script, because you know it easily becomes very confusing and so on. And let's organize our script. It's always good to do that because if you ever share this script with somebody else, which I actually should do, I should actually make it much more readable and name it before I post it online. Then everybody understands the script better and knows where are the different portions and how they work together. So we could name it, for example. So let's call that Honeybee Radiance video number 5. Could be also, of course, other description here, and I join this to one. So what are inputs? Inputs are, for example, the geometry, materials, shading, or apertures. And maybe you can, I mean, this is just you don't have to do it like this, but it's just trying to organize it a bit better. So I could have here, for example, sub titles, geometry, and materials. Or could be also that the materials are separate. Maybe that's even better. Let's keep these separate. Wherever we have a geometry, we want to put it in the geometry. For example, the apertures geometry. We can keep this here, and also the doors. I would just organize this now according to what I think is the best way at the moment. I mean, this is not fixed in stone or set in stone. It can always be changed, but it's I think it's good practice to give a bit of a tidy workspace, so it's much easier to control. For example, building programs can also go into the inputs. Okay, this is going to be fast forward. What this also does, it actually helps you to remove redundant inputs, because sometimes you just reuse the input several times, or you create inputs which are always the same, and they you don't need them because you already created these inputs before. Okay, see, much clearer already. There's not a right or wrong. A wrong would be if you don't organize it, then there's something wrong. For example, this one. I'm not sure where I should put this. Should I put it here? But then maybe there should be an input. Anyway, it doesn't matter. It's just a start, and maybe I change it. Here the title is twice. It doesn't matter. But you have clear groups of what you want to do. You have an input group, you have objects, where we create objects, transform it, and then we have the Honeybee model, a portion where we have a calculation, and that is perfect because then you can can have different calculations set up in this way, and you just change the input. And then you have the portion where you visualize. So let's save that. Okay, so for this example, I want to use the Honeybee annual irradiance analysis. Just because we haven't done it, okay, I've already pulled it out. So what is the irradiance analysis? The fundamental calculation of this recipe is the same as that of Honeybee annual daylight, in that an haste two-phase method is used to accurately account for direct sun at each simulation step. However, this recipe computes broadband solar irradiance in watt per square meter instead of visible illuminance in lux. Consequently, the average irradiance and cumulative radiation values produced from this recipe are more accurate than those produced by the Honeybee cumulative radiation recipe. Furthermore, because the hourly irradiance values are accurate, this recipe can be used to evaluate peak irradiance and determine the worst case solar loads over clear sky WEAs that represent cooling design days. So what do we need for it? We need the model. Again, we have our model here. This is the model output. This is just a visualization of the model. So the model comes out here. We can use that. And we have the weather data. We have the weather data here. Now I say, oh, it's very far away. Of course, I mean, you can arrange your script as you want. Just an example. But what you can use also is relays. I like relays. I'm not a big fan of the invisible strings because for me, it doesn't make it very clear on how the things are connected. But relays are very useful, I think. So we can connect this here. And we need the WAA object, which is this one. So we have that already, and we already plugged. They are different, by the way. They are not all the same. They're different ones. But you can also use any of these. You can also use any of these here. I mean, if you have questions about this object, I suggest that you Google it. What does ASHRAE clear sky, or the ASHRAE clear sky formula means? I'm happy with this one. It's the weather data. Seems to me probably the most accurate for if you do the model for a very specific location. Okay, we plug that in here. The other things we don't need to adjust. However, we have the radiance parameters. We will talk about this next time. Toggle, and then we can put the results These are the raw results. We discussed about that already. We can also get this the radiation, the peak irradiation, average irradiation from here. So let's go with the radiation first, and we can plug this in here, and we just flatten the list because we have 4 rooms, and here we join the meshes and we calculate for all rooms. Now what I want to do, I want to limit this the time a bit, because this is a much more elaborate calculation. It might take much longer, so I want to limit that to a certain month. So let's get the Ladybug period Ladybug analysis period, that's the one. We can, or maybe let's do a half year. It's probably better, so because then I show you how it works with the dynamic shading. Yeah, and day 31st. Start our set to 0 and end our set to should be 23, and that's my period. So I have a half year. Now we can run it, and then we go through dynamic shades. Because we have set here maximum minimum, and I have my minimum and maximum sliders here, so we can actually look at, because now we have a different unit. We have actually here the radiation, it's in kilowatt hours per square meter, and our maximum is 262, so we need to adjust our maximum. I go here and I'll go and put a bit more, so then it fits also to other studies, and push this up. Or let's do here, let's go for 250, 260, 280. So yeah, there's areas where we get relatively little radiation, and then where we get quite a lot. But yeah, the calculation took really long. Now one thing we actually forgot to do is to change the program. Change the modifier set, because as I told you about the modifiers, is that we have basic modifier set is set to the visible light study and not to the radiation study. So that means we should adjust that here. And how we did that was by going to the search modifier sets, and we had this like 3 different modifier sets. We can actually use human for that to select from the list. I forgot that we have this great feature. Otherwise you need to use some list item, and actually this should again go here if we're already doing this. So to be fair, this is actually should go here, and instead of materials we call this modifiers. And again, with human, this is another plugin. You get this item selector, which is very handy. Otherwise you need to do it in a way as I did it previously. And now it's gonna calculate again. We can just click it away, it doesn't matter. Or because now it's stopped anyway, I just disable it. That's good. And we also want to have the same modifier set here. And now we can select whatever fits to our study. In that case, we can actually use this one, generic interior solar modifier set. This is basically our base modifier set. And please check the other video about modifiers. So now we have set this one. We can, I want to talk about shades, but before we do that, I want to also quickly go through this one. So there's a tool which is called Honeybee Custom Ground, and that sets a different a boundary condition for the ground level, which I think is quite useful. It's a room which faces room faces that are coplanar with the ground surface or have a center below it will get the ground boundary condition. Because currently this face here is ground, but it's actually, it says outdoor floor or something like that. And if we set this, if we set the ground plane, then these areas, these surfaces become ground surfaces as an outdoor boundary, as a boundary condition. So we can do that. Can have our very simple plane. Oh, I plugged it wrong, and this should actually go here because it's part of the rooms. So we can connect that, add this to this group here, and we go from here to here. So we apply the ground to the rooms, which we already calculated, and then we add the apertures. And you can also do it afterwards. I mean, you can also apply it after the transformation if you want, or before the transformation. Okay, so this is one thing. That's one way to refine your model. Let's also kill this. We don't need that. I went a bit overboard with these relays. Yeah, dynamic shades. So Marcin asked, I think he asked, thanks by the way again. So this is really cool. So he was asking about these dynamic apertures. What I understood, these dynamic aperture groups, if I read it, then it's probably clear. Combine Honeybee apertures into a single dynamic group. Apertures that are part of the same dynamic group will have their states changed in unison. Meaning that if you have a dynamic group or you have a dynamic aperture, then its state, let's for example a window is open or closed, and that if you have that in the same group, then they all move at the same time, or they change their state in the same manner, in the same schedule. But for that, we need to understand schedules. Also, what I read that it seems like the aperture, the group, these dynamic states which you need in order to run these groups, they seem not to work. I get an error message, and I read that these are not ready yet. So I'm not sure exactly how that works, but you don't necessarily need it because we can run our dynamic shades, for example, through here. That just means that you have to apply, or you have to feed in all your objects you want to have dynamic into this one. It's much clearer when I show it then. So here we apply shading, right? So we have our Honeybee rooms with the windows and with the doors, and then we apply shading. We, for example, applied the extruded border shades. These are along the windows, these ones. Then we have louvers. This is these vertical. For example, imagine you have a deciduous tree. The deciduous tree is quite opaque during summer. It actually doesn't let much light through. In spring and in autumn, you have a transition where the transparency is changing, and then in winter you have very little shade, because all the leaves are gone. That you can control with dynamic shades. This is just an example. By the way, context shading is also plugged in here. For example, if you have a tower next to your building or another building next to your building, then this is also controlled here. So you can plug in a shade object here. So you can use the geometry, and now we get more. We can add another B-wrap, because you can have, of course, more titles. I'm just leaving it for now. So this now also becomes a shade, and now I need to just plug it in here. And here you can actually see, if we look carefully, we actually see that this slots here. Geometry, we can apply a name for that. Tower. Attached would be if it's attached to the building. Here you could apply a construction set. And then here is the E+ transparency schedule. And we also have a radiation modifier. So we could give it a material. So the E+ construction is about energy modeling. This is about radiation. It's about how it kind of affects the light, reflect light or not, and so on. And this is important here. So imagine we have a tree next to our building. I make a very simple model. Very simple model. Okay, this is my tree model. And for that, I want to now control its dynamic state. So I can add another shade object here, and I put this into here as well. Trees, and I can plug this in here, and this goes again here. Let's call it tree. It's calculating a lot already. And let's also add this here to the shading group. So, and now we need to apply a E plus transparency schedule. What is the schedule? Actually, it's really just telling Honeybee that, hoppala, we haven't added this model here. It's basically telling, it's basically adding a value, a factor for each hour of the year to inform Honeybee about its transparency. So meaning that 1 would be full opaque and 0 is transparent, completely transparent. And then you have the range in between. To make it more clear, I'll show you something which you might find really useful. Honeybee just doesn't come without anything, just doesn't come like this. As you installed it, it actually has sample files. If you go into your folder where you downloaded Honeybee, you actually find additional Grasshopper definitions, and one is called creating schedules. And if we look into this, then it actually shows us exactly how you create schedules, and it becomes much clearer what that actually does. And I will not go on exactly how these are done, but we actually can use these as components. Already, we don't need to reinvent the wheel. We can reuse that. It actually has other things here, like search the library, search the schedule library, create schedule type limits, deconstruct schedules, assign schedules. It's perfect. And we come to this in the energy modeling more and more. We will use that. Here's a seasonal schedule. Again, you can see it actually here. You have for each hour of the day, you have a number, a value. You can actually see here that in winter, it seems like it's completely transparent, which is probably not completely true because you have still the branches. It's really a start, and you can see spring is it's a transition period. It goes from 0 to 1, and then you have summer, which is 1, and then we have autumn, where it's declines again to 0. And of course, you can refine that up to your needs, really. But we can take this and copy, and we can reuse that now. And I would say these are also inputs. Yeah, we can really use that out of the box. Here is a cluster where the Honeybee developers were so nice to actually create this thing here, and this is how it's calculated. And if you want to change it. I will not do anything with it now. It's, I think, for this purpose of showing it how it works, that's perfect. You can see it's called here gradual transparency shift. We have the values which go in here, and this is just a list to show how the values look like. And this is our schedule, and we can use that to input here into that slot here. Now we applied that schedule to our tree, and now let's run our analysis. All right, so now you can remember we had like around 260 before, and now with all the shading, with the context, with the tower next to the building and the tree, we actually get much less. So we're around 130 now. But don't forget, we also changed the program, and that also has an influence on the output. Sorry, not this one. We changed the modifiers. The modifier set that also has an influence on the output. So probably not everything is because of the trees. We would need to run it again. I don't want it to take so long. It takes almost 10 minutes just to calculate that. Interesting. So, and of course we can look at the peak. It's then always also important that we understand the output and the average, the peak values. That's interesting, and also the average per grid sensor. Yeah, just realized that my camera was off again. Apologize for that. But yeah, I think it's becoming more and more interesting. We will just have one more video in Radiance for now, and then we move on into the energy modeling. So we're gonna look at the view-based, the image-based analysis. That should be hopefully very quick, but yeah, you never know. It always takes ages also to then talk through. Okay, so yeah, I will just share this script so you can check it out. Yeah, I hope that answers some of the questions. I'm gonna share the link in the show notes, and check out the sample files in the Honeybee installation folder. There's actually a lot to learn from. I wouldn't actually need to show you so much, but then I cannot make videos. That's the problem. No, but seriously, there's a lot of very useful. So there are already scripts ready-made for you where you can just reuse. But I would be careful that you don't overuse it if you don't understand what they do. That's a tricky thing with scripts which are already built. The danger is that you don't learn it, and then you don't understand. Then you don't understand it at all. The purpose of these videos is to how it works and to understand the different tools and how they are put together, or showing the possibilities of how they could put together, because the possibilities are almost endless, especially if you then look into using Honeybee with other plugins, not just Honeybee or Honeybee Ladybug. You can use the data in all kinds of ways you want, even outside of Grasshopper. Okay, next video is the last video for Radiance, and then we move into energy modeling. And then, of course, when we're done with the energy modeling, then I don't know yet, but then maybe we start to look into how can we combine it with other plugins and other software. Or we could also go through like one model, look at the whole process from start to finish within one video and take a real life example. But until then, there's still a lot to cover, and let's see where we get to. See you next time. Post your questions in the show notes.